The moon. A celestial object that has captivated humanity for millennia. Its presence in the night sky has been a constant source of wonder and inspiration. From ancient civilizations to modern-day astronomers, the moon has always held a special place in our hearts and minds. Its soft glow in the night sky has inspired countless myths, legends, and scientific inquiries. Ancient cultures wove stories around its phases, attributing to it powers and influences over human affairs. The moon was often seen as a deity or a mystical force, guiding the tides and affecting human emotions. For centuries we gazed upon its surface, wondering about its secrets. Early astronomers meticulously charted its phases and surface features, laying the groundwork for future explorations. The invention of the telescope opened up new vistas, revealing craters, mountains, and vast plains, sparking even more curiosity and questions. One question always lingered: is there water on the moon? This question became more pressing as our understanding of the moon's geology and environment grew. Water, a fundamental ingredient for life, seemed an unlikely presence on the barren, airless lunar surface. Yet the possibility intrigued scientists and dreamers alike. The presence of water is fundamental for life as we know it. On Earth, water is the cornerstone of all ecosystems, essential for the survival of plants, animals, and humans. In space, water is equally crucial, not just for drinking but also for producing oxygen and fuel. Finding water on the moon could transform our approach to space exploration and settlement. It's a crucial resource for any future human presence beyond Earth. Establishing a sustainable human presence on the moon would require a reliable source of water. This would support not only the astronauts' basic needs, but also the development of agriculture and other life support systems. The moon could become a stepping stone for deeper space exploration, serving as a base for missions to Mars and beyond. The moon, our closest celestial neighbor, became a prime candidate in our search for extraterrestrial water. Its proximity to Earth makes it an ideal target for exploration and study. Over the years, numerous missions have been launched to probe its mysteries, each bringing us closer to understanding its potential as a resource-rich body. The discovery of water on the moon wouldn't just quench our scientific curiosity, it would signify a potential game-changer for space exploration. Water on the moon could be used to produce rocket fuel, making it easier and more cost-effective to launch missions from the lunar surface. This could open up new possibilities for exploring the solar system and beyond. The quest to unravel the moon's mysteries, particularly the presence of water, has driven numerous space missions. From the early days of the space race to the latest robotic explorers, each mission has contributed valuable data and insights. These efforts have culminated in a series of groundbreaking discoveries, revealing the moon's complex and dynamic nature. From early probes to modern robotic explorers, each mission has added a piece to the puzzle, slowly revealing the moon's hidden treasures. The data collected has helped scientists map the distribution of water ice in the lunar soil, understand the moon's geological history, and plan future missions with greater precision. Join us as we journey through these discoveries and explore the profound implications of finding water on the moon. The story of the moon is far from over, and each new discovery brings us closer to unlocking its full potential. Together we'll delve into the past, present, and future of lunar exploration, uncovering the secrets of our celestial neighbor. The journey to uncover the moon's water reserves began with a whisper. It was a faint idea, a mere possibility that seemed almost too good to be true. The moon, our closest celestial neighbor, had always been thought of as a dry, barren rock. But what if there was more to it than met the eye? In 1976, the Soviet Luna 24 mission brought back lunar samples. These samples were meticulously collected and transported back to Earth, where they were eagerly awaited by scientists. Analysis hinted at the presence of water, but the findings were inconclusive. The data suggested that there might be water molecules trapped within the lunar soil, but the evidence was not strong enough to make a definitive claim. Scientists were intrigued but needed more concrete evidence. They debated and discussed the possibilities, knowing that a discovery of this magnitude could change our understanding of the moon forever. The possibility of lunar water sparked a new wave of interest. Researchers from around the world began to focus their efforts on finding more definitive proof. New missions were planned and advanced technology was developed to search for water on the moon. If water existed, where was it? How much was there? These questions became the driving force behind numerous scientific endeavors. The search for lunar water was not just about quenching curiosity, it had practical implications for future space exploration. Could it be a viable resource for future missions? Water on the moon could mean sustainable human presence, fuel for spacecraft, and a stepping stone for deeper space exploration. These questions fueled the next chapter in lunar exploration. The quest to find water on the moon was no longer just a scientific curiosity, it was a mission with profound implications for humanity's future in space. In the 1990s, NASA's robotic missions provided groundbreaking evidence that would change our understanding of the moon forever. These missions were meticulously planned and executed, aiming to uncover the secrets of our closest celestial neighbor. The Clementine spacecraft, launched in 1994, was a pivotal mission. It used sophisticated radar technology to scan the lunar surface, particularly focusing on the moon's polar regions. The radar data collected by Clementine indicated the presence of ice deposits, especially in areas that are permanently shadowed and never see sunlight. These permanently shadowed craters, located at the lunar poles, are some of the coldest places in the solar system. The data suggested that these frigid environments could harbor frozen water, hidden away from the sun's warming rays for billions of years. Further confirmation came in 1998 with NASA's Lunar Prospector mission. This mission was designed to map the moon's surface composition and to search for signs of water ice. The Lunar Prospector carried a neutron spectrometer, an advanced scientific instrument capable of detecting the presence of hydrogen. Hydrogen is a key component of water, and its detection was crucial for confirming the presence of water ice on the moon. The data from the Lunar Prospector revealed higher concentrations of hydrogen at the lunar poles. This discovery significantly strengthened the case for the existence of water ice on the moon, providing a foundation for future lunar exploration, and the potential for utilizing these resources in human missions. Lunar environments, where water hides. The moon lacks a substantial atmosphere like Earth's, which protects us from the sun's harsh radiation and helps regulate temperature. This lack of atmosphere results in extreme temperature variations on the lunar surface. However, at the lunar poles, deep within craters that never see sunlight, temperatures remain perpetually low. These permanently shadowed regions, often referred to as cold traps, become ideal locations for water ice to remain frozen and undisturbed for billions of years. Recent discoveries, a game changer. In recent years, lunar missions have made significant strides in confirming and characterizing lunar water. India's Chandrayaan-1 mission in 2008 carried instruments that definitively detected water molecules on the lunar surface. NASA's L-Cross mission, also in 2008, intentionally impacted the moon's south pole. The impact ejected plumes of material, analyzed by scientists. The results unequivocally confirmed the presence of water ice in significant quantities. The significance of lunar water. The discovery of lunar water has far-reaching implications. It's not just about understanding the moon's geological history, it's about the future of space exploration. Water is a vital resource for human survival. Beyond drinking, water can be broken down into its components: hydrogen and oxygen. These elements are crucial for rocket propellant and breathable air. The presence of usable water on the moon could dramatically change the economics of space travel. Future prospects. Living on the moon? The discovery of lunar water has fueled ambitious plans. Space agencies and private companies are now seriously considering the possibility of establishing a permanent human presence on the moon. Imagine a future where the moon serves as a launchpad for missions deeper into our solar system. Lunar water could be utilized to create rocket fuel, reducing the need to transport it from Earth. This could make space travel more sustainable and cost-effective.